Hopefully everyone can hear me. Yes. Okay. Minimize all those things. Go back to that. Okay, cool. So this session is orchestrating Lambda with STEM functions. And kind of a technical session. My goal is to show you what's amazing about Lambda, but also how you can make it even more amazing with something called step functions. So, you ready to get into this? Here we go. Of course, I like to start off a lot of my sessions with selfies. And here's me and my wife. We're on the Arno River in Florence, and we're looking back at the Ponte Vecchio. And this is where my wife and I went for a vacation back in September or so, and it was amazing. We stayed at a friend's apartment. I got to see Florence like a native. It was amazing. And from there, we drove out to Tuscany. And one morning, I get my camera, walk out right outside my door, and I take this photo. And it's just this beautiful place. We had such a great time. Now, why am I showing selfies at the beginning of my presentation? Well, it has to do with a technology decision and a promise that I made. A promise that I made to my wife just a few weeks before. I told her, I'm not going to bring my laptop. I'm going to go without technology. Okay, I brought my iPad, but for the most part, I'm going to go without my laptop, because usually if I'm with my laptop and I'm in this beautiful location, I'm not going to be out there. I'm going to be doing my own little thing. So I told her, no, I'm going to leave my laptop at home, and I'm going to enjoy this vacation with you. It's going to be amazing. Now, it also, the reason it's related is because this technology decision. I had recently just switched my personal website from WordPress on DigitalOcean to Hugo, and then Gatsby.js on S3. And Gatsby is this amazing, as well as Hugo, are these amazing static site static website generators. Really, really cool technology, really easy to get started with. And you can build these, as it says, blazing fast static sites. So that's great. So why is that? Well, first off, what's different about WordPress versus something like Hugo or Gatsby? Well, with any of these things, you're probably going to have your machine that you're working from. You're typing away, you're making your website on your local box, and then you upload it to some server way up in the cloud. And in the case of something like WordPress, you might be using WP Engine or plenty of other hosting providers that are out there. And you might be paying, you might be paying a little bit of money or a lot of money. But anyway, you've got a user and they make a request to the server. And when that request comes in, the server has to process it, has to think about how to generate that page. And when it does, it serves back the page. And it could take very little time or a lot of time, depending on how complex your server is or how complex your logic is and how much you're paying that provider. Now at Datadog, we were working with WP Engine, and then we ended up switching to a different provider. I can't remember why, mostly because WP Engine was having all sorts of problems going down because their provider was kind of clueless, a company called Linode. And having a lot of problems. So we switched, and then we switched to a static site generator. But before we made that switch, our WordPress site, from the initial request to the final, it's finally available, was upwards of like 8 seconds. For that full page to be rendered. And so that's the way WordPress works. If I were using a static site generator, I'm still working on my local machine. I'm still using some hosting provider, but I do let compile time. The compile time happens, or most of the work happens on my laptop. I compile it, and then I just upload HTML and CSS and JavaScript. And then when a user comes in and makes that request, they get a response almost instantaneously. And so in the case of Datadog, we went from a full load time of 8 seconds because, we have a lot of developers working really hard at making that marketing site really fast. But marketing also wants to have all their little plugs in there. And so it took a little bit of time. But now on this, we're using Hugo at Datadog. It's a really slow day when it takes longer than about 800 milliseconds to render that full page. So we went to a static site, and I've been using static site generators as well personally, because I don't have a lot of people coming to the site, but it's nice it's a nice thing to work with. So who am I? I'm Matt Williams. I'm an evangelist for a company called Datadog. Kind of curious, how many of you have heard of Datadog? Wow, that's great. So I've been doing this job for about 3.5 years. When I first started, I would ask a crowd of, let's say 100 people, and one person, two people might raise their hands, and now I'm seeing half the room. In fact, I was at reInvent, Amazon's big conference, and had a room of about 400, 500 people, and I think about 3/4 of the people raised their hand, and probably about a quarter were customers, which is also awesome. Anyway, I have. If you have any questions about this session or any questions about Datadog, you can reach me on Twitter at TechnoEvangelist or mattw@datadoghq.com. I also am an organizer of an event in Boston where I live called DevOps Days Boston. We had a really great event last year, and we're looking forward to a great event this year. One of our speakers from last year is right here up in the front row, and is going to be having a session right after mine. Where is your session?
In the main room downstairs.
The main room downstairs.
When is DevOps?
DevOps Days Boston is going to be in September. So we're in the planning stages right now. There's a lot of planning required in an event like that. Who is Datadog? Well, we're a SaaS-based monitoring and analytics firm. We do infrastructure monitoring, we do application performance monitoring, we do logs, and we have this open source agent, and we're bringing in trillions of data points every single day. When I started at the company, we were very excited that we hit 12 million data points per day, and we hit about 1 trillion a few months ago, and now we're in the many multiples of trillions. And we're hiring, like so many companies that you'll see, that you've seen at the last 2 days and any event. We're hiring. We're hiring as much as we can. When I started, we were 40 employees. Now we're about 580, and our goal is to be about 1,000 by the end of this year. So we're hiring for every possible role. If you're good at what you do, we'd love to hire you. Now, what's that? Yeah, so our main office is in New York City. Our mostly sales, but also some developers are in Boston. We have another really big office in Paris, and because the two founders are French. And but then we've got lots of other. We have now 16 offices, and one of those offices was because one of the guys decided to move closer to his family in Nevada City, California, and now we have an office there of like 5 people. And but we have plenty of others that are scattered all around the country and all around the world. So if you're good at what you do, we don't really care where you are. It's great if you're in New York, but there's plenty of people who are all over the place. So I love to talk about serverless, about Lambda, about lots of other serverless technologies. And this is actually a photo from not this last year, but the year before at reInvent. That's when the show was a little bit smaller than it is today. It was only about 35,000 people. Now it's about 50,000. I think this coming years, they're looking like 70, 80,000 people. But they didn't all fit in this room. This was a small room. This was only about 1,800 people in that room. It was a really cool room. It was built for Phantom of the Opera. And so they're flicking candelabras. It was really beautiful. Anyway, I like to talk about serverless, and in this case, I was talking about serverless and monitoring. And this is not reInvent. So maybe you aren't familiar with clouds in general. So there's 3 big clouds. There's AWS, Amazon Web Services. There's Microsoft Azure. Yes, you might think it's Azure because that's the way I always thought it was pronounced. But then Microsoft said, nope, it's Microsoft Azure. Okay, fine. Microsoft Azure, there's Google Cloud, there's lots of others, and all of these servers, or all of these clouds, they offer a lot of different services. What kind of services? Well, here's what I got when I logged into the Amazon console. These are most of the services. There's a few that are down here that didn't fit on the screen, but there's a lot of different things on here. And a good half of them, I have no idea what they do. But so they have a lot of different services. Choose whichever one you like, and you can. And just because you choose one cloud doesn't mean you're stuck with that. You could totally build an application that uses some of AWS, some of Azure, some of Google, whatever you want to do. But what is Lambda? Well, Lambda is serverless. Now that is one of those terms that gets all sorts of people all riled up. It's like, how can it be serverless? Of course, there's a server. No, there's no server as far as you're concerned. You don't have to care about a server. You don't have to worry about maintaining a server or patching a server. You know, when the next 0 day for Linux or SSH or something else comes out, that's not your problem. Amazon's going to take care of it. Amazon has amazing people, and Microsoft and Google. They have operations people who are better than you at everything you're going to do. And so they're going to make sure that these things are totally up and running and totally up to date. And you don't have to do that. So as far as you're concerned, yes, it is serverless. There's nothing that you need to do. You just focus on your function, your functionality. Whatever your company does, just focus on that. What's really great about it is you don't pay for idle. So if, let's say you've got something that runs maybe just a few seconds every day or a few minutes a month, you just pay for that time that you're actually using. You don't pay for all the downtime. You just pay for when you're using it. And you can scale with ease. Well, how much? Well, I don't know of a real limit. There's some artificial limits put in place just so that you don't do something really stupid. Because it's really easy to do something stupid that will rack up your bill. But they put this artificial limit in there so to ensure that you don't do that. And it's function as a service, and there's lots of languages you can use, but I like to use Node.js. 6.10 is what I'm using, but you can also work with Java and Go and Python and C#, and it's trigger-based. Well, what's trigger-based mean? Well, there's a lot of different things that can trigger a Lambda. S3 is where you store files, and so every time you upload a file, it can trigger a Lambda. DynamoDB is a database. Every time you add or subtract a row from the database, it can trigger a Lambda. SNS, Simple Notification Service, or Cognito for authentication and authorization. As soon as a user is authorized or not, maybe that triggers a Lambda. One way that we use Lambda at Datadog is when I create a security group that gives maybe a virtual machine, access to a virtual machine from the outside world. If I give it access from anywhere in the world, within a few seconds, a Lambda runs, sees that thing, and within a few more seconds, I get a message in Slack saying, you did something stupid and opened it up the world to potentially some of Datadog, close it, or you're going to lose your AWS privileges. And when I haven't answered that, I've lost my AWS privileges. Now it got restored when I fixed my stupid mistake. But that's one of the ways that we use Lambda inside of Datadog. So what about Google or Microsoft? Well, yeah, they have solutions as well. Google Cloud Functions and Microsoft Azure Functions, or I said Microsoft Azure Functions. Google Cloud is just Node.js. There's the promise of Go coming soon. It's been coming soon for the last year or two. And Azure Functions supports C# and Node.js and F#. They all have similar triggers, not as many as AWS, but pretty much everything from the previous slides apply to them. And so you can kind of think of Lambda and serverless in general as the next stage in this progression, trying to pull you away from having to manage your own server. So you started with this physical box. You buy a box from Dell or whoever it was, plug in power, turn on the cooling, plug in the internet, and you've got this box. You've got to take care of it. It's like a pet. You got to make sure everything's all working well. And if something breaks, you got to fix it. And we then got virtual machines to be able to take better advantage of all the processing power on that box and move on to AWS instances where those virtual machines move into the cloud. And then containers, containers come along. Of course, we think of containers with Docker, but of course there have been C groups and jails before that. But we got containers to take better advantage of those virtual machines or even your physical boxes. And then we come to Lambda. Oh yes, Lambda. We've got this thing that where I get to focus on just the functionality I care about, and not all this other stuff. I don't have to worry about the server. I don't have to worry about patching. So what's it look like to build your first Lambda function? So I created this just a couple weeks ago, logged into the AWS console and created a really simple function. So to get started, you go to the Lambda area, you click on Create Function. And then you can either author from scratch or start with a blueprint. Now, blueprint is kind of like a template. And there are a lot of templates that are already up there, and you can kind of look through the different templates that are available and see if there's something that interests you. Or you just go back to author from scratch. So when you author from scratch, give it a nice name. My demo function is a nice name. I usually like to throw on MattW at the end because you'll quickly end up with potentially hundreds or even more Lambda functions that all have crazy names, and you'll never remember which one's yours. So I like to throw on MattW on the end. That way, that's me. Then you can choose a runtime. There's a lot of runtimes to choose from, but I'm going to go with Node.js 6.10 just because that's what I prefer to work with. And then choose a role. Now, roles are really wonderful. There was once upon a time, a few years ago, you probably would, if you wanted to share your access with your AWS account, you'd give that third party your access key and secret. And now, if they do something bad, it's really hard to revoke that because you've shared the same key and secret with everyone in the world, and it just gets difficult. So with roles, you create a role, you give access to that role, and then hand out that role to any individual. And when they do something bad or your application does something bad, you just revoke that one role, and it's just a lot easier to deal with. So I'm going to create a role from a template. So I'll give it a lovely name for a role, like my demo function role MattW, and then choose a template. Templates are really nice for generating your role because S3 object read-only permissions is not just give it read-only permissions, but I need to give read-only permissions to list out everything in the S3 bucket to get the object out of S3. And there's like 3 or 4 others that you need to get the full read-only permission. So I'll choose S3 object read-only permissions. And then we can click on Create Function to actually create our function. So it turns a little bit. And then boom, you've got this function. You've got the coolest function that says, hello world. And I can see that right here, I've got access to CloudWatch logs, and I've got access to S3. But it doesn't really do anything automatically yet. I need to turn on a trigger. We talked a little bit about triggers, but the triggers are here on the left side. And there's a lot of triggers that I can choose from. And so I scroll through, you can see the Alexa skills or CloudWatch or Cognito. But I want to choose S3 as my trigger. So I choose a S3 bucket, place for all of these files to go to. And I want to say anytime somebody creates an object in my S3 bucket with a particular prefix and a particular suffix. Anytime that happens, then it's going to trigger my Lambda. So click on Add, and I'm good to go. So now I've got this function. As soon as a file shows up in S3, my Lambda function executes. And as soon as 10,000 show up, I get 10,000 Lambdas. Okay, I really get 300 because there's that artificial limit that's put in place, which I can increase if I want. But but it could be up to 10,000 or more. So now I click on the name of the function, and I get this editor. Now, a few months ago, up until a few months ago, if you clicked on that function, you would have gotten this super useless text box. Text box that you would look at, oh, God, that's so awful. But now you get Cloud9. Cloud9 is spectacular. So Cloud9 was a service, Cloud9, C9.io for a long time. And then AWS acquired them, and everyone's wondering, well, what's going to happen? Where was this really cool IDE? Is it just got dead? Or they just was it an acqui-hire? But they've turned it into the default editor for Lambda. But then there's also this Cloud9 service, another service on AWS, where you can turn it on, and you'll get something like this. You'll turn it on with an EC2 backend, and now you've got this full IDE, and it's a pretty cool IDE. It works really, really well. I see all my Lambda functions on the right side. I see all my code, some really bad code here, but I see the entire application, my entire Lambda function all there, and I can edit. I can, if I want to add another NPM module, that's really easy. Just add it. And what's even better is I can do step as it's live on AWS, which nobody really offers. Debugging Lambda is really, really hard. And finally, AWS has made it a little less hard, a little bit better. So I'm really excited about Cloud 9. So that's pretty cool, right? But it's not perfect. I still have to go in and configure everything else that my Lambda works with. I have to still configure S3 or Dynamo, my database, or my API gateway, which is my HTTP endpoint. I still have to configure all that. Now, there are definitely tools out there to make it easier, like SAM, a serverless application model from AWS, or CloudFormation for defining my Kinesis and my DynamoDB and my API gateway. I can define all that in CloudFormation templates, or I can use something like the serverless framework, which just for me makes everything a lot easier. Now, I showed this image where we go from physical boxes to virtual machines and so forth up to Lambda. But it's a little bit deceiving. You'd almost think that, well, containers are the same thing as Lambda, but serverless is not the same as EC2. Serverless is not the same as an application, because applications are complicated. And serverless functions should respect something called the single responsibility principle. Now, if you're not familiar with the single responsibility principle, we can go to the source of all knowledge in the world, Wikipedia. And it tells us that single responsibility principle basically says, every function should do basically one thing. Should always do one thing. And there are a lot of examples of serverless and Lambda functions on the internet that try to do 10 things or 100 things all in one Lambda function. And really, you should try to keep them simple. Do one thing at a time, just one thing. And so maybe a better version of that diagram of those 5 boxes is something more like this, where my container is replaced with a bazillion different Lambdas, because each Lambda is going to do one thing. And to recreate an application, you need a lot of Lambdas. So you can create a lot of serverless functions, but how do we orchestrate them? How do we get them working together, communicate as part of a larger application? How do you get that done? So there's been a lot of examples, a lot of ways to do this in the past. There's been using event streams and message queues and databases as a traffic cop. For an event stream, you might use Kinesis. For message queuing, you might use Amazon SQS. For a database, you might use DynamoDB. And these are all great solutions that other people have done and worked with. In fact, Nordstrom has this great example on their GitHub area called Hello Retail. They've got a Hello Retail workshop that guides you through building out this exact environment. And it's using Kinesis in the middle. And we've got Lambdas that are talking to Kinesis and starting up other Lambdas. And this is a scenario where you've got product managers adding products to a repository, and then photographers coming in, adding photos of those products, getting approved, generating the website, notifying them by SMS using Twilio, and all sorts of other things, all together in this one application. But this is not a perfect solution, because now each one of my Lambdas needs to know about Kinesis. It means that my Lambdas are not loosely coupled. They're not, they have to know specifically about this application. And it makes it very hard to move a Lambda from one application to a different application. And if I want to replace Kinesis with DynamoDB or whatever replaces Kinesis in 2 years or 5 years, it's going to be really, really hard, because all my Lambdas know about Kinesis and know exactly how that works. So managing and getting all these things working together has always been really hard. But now we've got something called step functions. Step functions are super, super cool. Step functions are a way for me to link up lots of different Lambdas into a workflow. So here I've got lots of different Lambdas that create my image conversion application. So on Google, yeah, we could do a database thing, and so there's Firebase. Firebase is pretty awesome, but they don't really have anything like step functions on Google. Now, Azure does. Azure has this service called Logic Apps. Anybody heard of Logic Apps? Yeah. So, oh, okay. Well, one person has heard of Logic App. That's great, because that is one of the only people. And since I heard about this back in January, I think the talks I've done, I've been in front of maybe 600 or 700 people. I think there have been like 2 or 3 that have heard of Logic Apps. Logic Apps are super cool. There's a more consumer version of it called flow.microsoft.com. And I was asking I was telling my wife about this, and she said, "Oh yeah, I use Flow all the time. I use it in, she's an architect. She was here yesterday, and she was, oh yeah, I use it for when a diagram shows up and there's certain information in this database, I get automatically pull that into using Flow." She went really into. She was really excited about it, and that showed me that okay, this is for regular people as well. But Logic Apps is on the Azure side, and what's different, so it's, imagine, if you're not familiar with this, imagine what you really loved if you really loved Yahoo Pipes back a few years ago. Yahoo Pipes was amazing. And then you've got If This Then That and Zapier. And think of those two combining and like pumping with steroids, and you've got Logic Apps potentially. Some of the documentation a little weak, but there's a lot of potential in here, and I'm really, really excited about it. And what's interesting about Logic Apps versus Azure, or about Flow, is that any of these endpoints or any of these things that you do could also be Azure functions or anything else that you can get in the Azure area thing. So that's really, really neat. I'm excited about that. So a step function. We're talking about AWS. A step function is a state machine. So what's a state machine? A number of years ago, I worked for a company called Teamplate. Teamplate did a workflow solution. They're based in Calgary, Canada. We would sell this workflow product, and people say, it's not workflow, it's a state machine. And other state machine products were out there, and they said, no, it's not a state machine, it's a workflow. And there's so much confusion around what's a state machine versus a workflow. But essentially, you can think of a state machine as generally a workflow. Some academics will be very upset at that definition, but a state machine is generally a workflow. Well, Amazon has a workflow solution. What about that? Well, there is Simple Workflow Service. And if you're using it, stick with it. It's not going away. Everything's all good. But if you're not, don't use that, because it's really complicated. I don't understand how to work with it. But step functions, it just makes sense for me. So some step function concepts as a state machine. I talked about that. There's a bunch of states. I'm going to talk about those. There are transitions. So every time a moves from one state to the next, it's a transition. And in fact, transitions are what you're charged on. So you might think, oh, well, that's going to get expensive. You get a lot of transitions for very little cost. In fact, it's if you do 1 million transitions, that's going to cost you $25. So it's relatively cheap compared to the amount of effort that would be required to replicate this. You define a state machine with Amazon States language, and it generates a nice, pretty diagram. So let's take a look at some of the states. So the first one is a task. Task is like a Lambda function. And so anytime you want to run the Lambda function, that could be one of the states. So it's a task. And there's it starts, and then it moves on to the next task. The next one is a choice. And so maybe your task spits out some variable. Variable foo equals 1. And so you've got a choice. If foo is equal to 1, go run the first task. If foo equals 2, run the second task. This has two choices, but there could be 1,000 or a lot. Succeed or fail. It's really useful at the end of a state machine, or at the end of a step function, to know whether it was successful or a failure. It can go all the way through the entire thing and still be a fail. It's not an error, but a fail. And that way, when you're looking at all the long list of all the step functions that were executed, you can see which ones were successful and which ones failed, which is really useful. You can do a pass. Pass is great if you're just building out the step function the first time. You've got a placeholder, or it's not working quite right, and you want to inject a value after a task, and you want that to save additional data. You can wait. You can wait for any amount of time, either time defined by the previous task or time, every 20 seconds you want to check this thing again, which is something that I do in my demo, which I'll be talking about soon. There's parallel. Sometimes you want to run many different parallel tasks all at the same time. So do all these things, and then do all things, and do all of these things. And when all of those are all done, then move on to the next task. So there's a lot of different ways to build step functions. I happen to really like using the serverless framework. So there are a lot of different frameworks out there, but one thing I really like about serverless framework is I can define everything in a single file. I can define my IAM role statements, giving access to my Kinesis streams and my DynamoDB, defining that all in the same file as defining my handlers, my step function handlers. The job, in the case for me, I'm using Node.js, so the functions, the Node.js functions, and triggers, and all the step function states, and defining my CloudFormation template, all in that same one file. Find it all one place. Okay, there's a few other files, but generally all in one place. I define it all, and then I've got my entire application, including all the Lambda functions and all the states. Really, really cool. So now let's talk about my little demo. So I don't have a live demo because part of my live demo kind of broke. But generally, when thinking about demos, when you're doing demos in any kind of event, one thing you should always keep in mind, keep it as simple as possible. You want to keep it as simple as possible. That way, if something breaks or something doesn't work right, it's an easy fix. Keep it as simple. Just get the information you want to get across to find, in your demo, and don't go any further. The problem with that is just so boring. So I go with the different approach of making it as complicated as possible. And I find this a lot more exciting. It gets me all sweaty. It's just great. So this was all the different tools that were involved in my demo. Now, what was my demo? I was live blogging my reInvent session while I was presenting my reInvent session in front of 400 or 500 people. I know, it's so incredible. You want to sneeze every time you see it. So the way I did it was I've got a I don't think I have it. Oh yeah, here it is. I've got one of these little Raspberry Pi Zero with a camera module on the front of it, and it's right in the front row, taking pictures of my slides every 30 seconds. Every 30 seconds, it's taking a picture, uploading it via API gateway, saving that file to S3. S3 is then the fact that a new file shows up in S3 triggers my step function and my lambdas. And the first lambda hands it off to, works with a third-party service called Vise.ai, which is the part that broke. But it hands it off to Vise.ai, which is this third-party machine learning service. Now, ahead of time, my slide deck had, for reInvent, had like 80 slides. And so I generated about 70 images of each one of those slides in different orientations in 3D space with at different depths, and then having random backgrounds behind it. And that created my data set for each slide. And I uploaded them to Vise.ai and said, this is slide 1, these 80 slides are slide 2, these are slide 3. And then as I'm doing my demo, it would upload to Vise.ai the current picture of the current slide. It would say, oh, there's a 99.9% chance that you're on slide number 22. Pull in data from DynamoDB about my notes for that slide, generate a new Markdown document, and then kick off a build of Gatsby.js that would then generate my static site that was live blogging my presentation at reInvent. It was really cool, and it really worked. Kind of. It definitely said there was like a 99% chance that it's slide number 22, even when it was slide 13. But hey, it was a cool concept. It was amazing, and it was a lot of fun. So what are the different tools that are here? There's Code Commit. If nobody's ever heard of Code Commit, don't worry. I don't know if anyone's actually using it, but it's it's hosted by AWS, not GitHub, but hosted Git. It's kind of weird. There's Amazon S3, which is a storage, where you store files. ECR is a container repository, kind of like Docker Hub. Step functions, well, it's a step function salt, so I got to use that. Lambda, it's a Lambda talk too, so I got to use that. IAM for defining my roles. CloudFormation was where I defined those templates that define how to build out my Kinesis, and I keep using Kinesis, but DynamoDB and SNS. SNS is simple notification service for sending out emails, but also sending out text messages. In the process of building out this demo and actually doing the live demo, I ended up with about 1,000 text messages on my phone, which is really exciting. Code build for building whatever you want. It's just a Docker building service. In fact, code build is super cool. Even if you don't want to build anything, if you just want to do something and you want to do it for free, code build is cool because they give you 100 free minutes per month to do whatever you want in a Docker container. 100 free minutes. Then I thought that was really cool. And then I saw that Google has Google build, container build something service that gives you 100 free minutes per day. And that goes on forever. So, so that's really cool. So code build, and then Google's version of it was really neat. API Gateway is an HTTP endpoint. CloudFront is kind of like a CDN. DynamoDB is a database. Gatsby, I mentioned Gatsby already, static site generator. And Vise.ai, that thing, that glue in the middle that's super important. Small company, like 2 people, 2 technical people, and they got acquired a few weeks ago and pivoted to something that doesn't involve my demo. So unfortunately, I can no longer do my demo, but I'm in the process of building it out again using Amazon's machine learning tools, and so hopefully I'll have something really cool soon. So I built a bunch of step functions. These are some of the step functions I built for building out my site, and this was a page from the site. This is one of the accurate pages from the site where it said, you're on slide number 22, and all of the event message database as traffic cop solutions are hard. Hey, and there's a 99.999% chance that this is slide 22. It was amazing. And so you have to go to page 4 to get something that's totally accurate. But still, it was really, really cool. And this is generally what happened. I've got my Raspberry Pi on my little tripod, pushing to API Gateway, which pushed to S3, which triggered off Lambda, which triggered off step functions, handed off to Vise.ai, grabbed some data from DynamoDB using Lambda, triggered off a code build also via Lambda. So let's take a look at how I did this. So here's my serverless YAML file. I'm using serverless framework, and I've got, I define a service name, Matt W. reInvent 2017 live blogger seemed like a good name, and I'm using some plugins, serverless webpack. So I mentioned that it's Node.js 6.10, it's a long-time support version. But it's not the sexy version of Node.js. It's the version that's, going to be supported for a long time. But I want to use the sexy features of Node.js. I want to use async await. I want to use decorators. I want to use all those things, those fun things. And I can't. So I use Webpack to kind of transpile it down to something that 6.10 will understand. Pseudo parameters are great for not having to remember my AWS login information, or not login information, but like regions and account numbers and all those types of things. So it just kind of plugs that in based on what it finds in environment variables. And then serverless step functions, it's a step function called, so I got to use step functions. And then I define a provider. So serverless framework works with AWS and Azure and Google and a bunch of others. So I'm on AWS for this. And I'm using Node.js 6.10, and then I can define some IAM role statements. So I want my all my Lambda functions and the step functions to be able to read and write. What am I doing? I'm saying allow everything on my S3 on this particular bucket. And I'm also allowing it to start execution of my step function, which is defined in the self-resource outputs in later on. I also wanted to allow it to get an item from DynamoDB from these particular database tables. And this is where these variables come in, AWS region, so I don't have to type in US East 2 or US East 1. So that's pretty neat. And then functions. I start defining my functions. The first function I want to define is upload to S3. So when my Raspberry Pi uploads a file, connects to a HTTP endpoint, it's really pointing to this HTTP endpoint. So I define a function called upload to S3. This is where the code is in the handler.js file. There's an upload to S3 function. I define some tags because tags are fun. And then I define a HTTP event. And so serverless framework is automatically going to create an API gateway endpoint. It's going to be a put method on the path upload. And it's got an environment variable of this S3 bucket where it's going to actually upload. And so here's my entire function. I'm not going to show you a lot of code throughout this, but here's one bit of code where I'm uploading a file. And really, I'm just the minimum amount of stuff to be able to write a file to S3. Not really a whole lot going on there. And I guess I got a little bit of error catching, but pretty simple stuff. And then I've got a next start step function is my next function that I'm defining. It's a handler of start step function. And it's triggering, the trigger event is anytime a file shows up in this bucket with object created event, then trigger my my start step function, Lambda function. And I'm defining an environment variable of this state machine ARN. And so start step function, really all it's doing is grabbing the ARN of the step function, grabbing some details from what triggered this, and then just starting the step function. Pretty simple. So now we get into the step function. So here's my entire step function. And this is the step function for actually building out my site. And so up the top, it's basically using machine learning to figure out which slide I'm on. If this slide is different, is the slide different? And if so, pull the slide data from Dynamo and also generate that document in S3, then go ahead and build the site and wait for it. That's where that wait comes in, because building the site doesn't take 2 seconds. It takes about 1 minute and 30 seconds. And so I have it wait 20 seconds and then come back again. Oh, nope, still, okay, come back again. Oh. So it keeps going through this loop, waiting until it's finally done, and then it's done and sends me an SMS. Again, 1,000 SMSs. So the first task is which slide am I on? And it's a resource of type of Lambda function. It's a type of task. And the input that comes into it, so these are all parts of the UI. You know, I define my step function, and now I can see this thing is automatically generated. And when I click on that, I see input and output, and if there were any exceptions. But the input to this step function is the bucket ARN and the file name, which is really important. And then I'm just handing it off to Vise.ai. So this is just code to basically make a REST call to Vise.ai. And Vise.ai reports back saying, it's probably slide 3. Here's the full file name. And here are all the different, what it thinks. You know, okay, there's a 0.000 chance that it's slide number 10 and slide number 11 and so forth. And then on when it gets to slide 3, way further down, it will say 99 point something. The next task is, hey, is this a new slide? And so is this a new slide? Just says, what was the last slide? What's the current slide? Is this different? And then, so I've got some pseudocode here. And but for this update site is true. So go ahead and update that site. And then create document is the next task. Good luck on your session. Thank you. And it's running a Lambda function. So the code is just generate that post text and writing it to the buffer and saving to S3. Then it starts building the site. And the Lambda function for that is just get that last commit ID and start the code build. And this is where things get kind of interesting. Oh, it's a bad color for this projector. Oh, well. So the important stuff is in white, but I can split up my kind of script into sections, like I call it build, post-build, and artifacts. And I'm not really having to do anything that, you know, it's just a Docker container. And so the first thing is S3 sync. So AWS S3 sync. Grab everything in my AWS bucket and pull it into this container. And then I do a build, Gatsby build. I'm linking up a few directories. That's kind of weird, but I'm doing this Gatsby build. Now, for this process, I generated my own Docker container. So there's a separate step function. If it's Docker related, it will rebuild my Docker containers. And I do a multi-stage build of my Docker containers. It's kind of a neat way of building out really fast Docker containers where you build out a Docker container, installing all your files, and then you build a second container, copying files from that first container. And so you can define basically 2 containers within a single Docker file, and then it deletes the original container, and now you end up with all the installed files minus all the installation extra stuff. So that's a really great way of doing it, and I was able to shave about a minute off of every build by getting rid of all that installation cruft that it would have to load. It was really, really worth going, a worthwhile exercise, even though it took a long time. And then once that's done, then do a sync of my public directory back into a different S3 bucket, which has public read, and then that's my site hosted. So that's a little bit about that demo. But I work for a monitoring company, so let's try to make this relevant to Datadog. We monitor Lambda via logs, and there are a lot of different ways of monitoring Lambda. You could monitor based on, you could just rely on the metrics that are provided by Lambda, which isn't that much. You could also load up an app, a framework into the Lambda function that writes out to whatever service you're using, whether you're using Datadog or Sysdig or one of our other competitors out there, writing to one of them. And then, but now you're loading up that framework inside of your Lambda function. You should try to get those Lambda functions as simple as possible. Anytime you're loading up additional NPMs, it's potentially making it slower. And even if it's only making it 10 milliseconds slower, that times 10,000, it all adds up. So that's not really a great solution. There's also, there's another way that I can't think of right now, but writing to logs is a nice asynchronous way of recording the information that you want to record. And so we just write to the log file with the format of monitoring all in caps, pipe, time since Unix, epoch timestamp, a value that you want to save, and what kind it is, whether it's a count or a histogram or something else, what you want to call your metric, and then a bunch of tags. And so you just, in the case of Node.js, it's console log, that monitoring string. And that's how you'll record something. And then we've got a process on the back end that goes through all your CloudWatch logs every few seconds and turns those into metrics. But you could also rely on Lambda. So Lambda is going to automatically generate these metrics. There's actually 1 or 2 others around the dead letter queue. But these are essentially the metrics that are collected automatically by Lambda, but they're only updated once every minute because that's the way CloudWatch works. And then there's also some metrics around step functions, like execute, how many times was it throttled, how long did each one take, and all sorts of other things. There's another framework that I just found out about on Friday that could be worth looking at if you're using Datadog, if you're using serverless framework called plugins or serverless-plugin-datadog, I think. And that will give you all sorts of additional information, additional metrics around the cold starts and other specific node information. It looks really cool, but I haven't had a chance to play with it. In summary, step functions are a really great way of making Lambda orchestration easy. Step functions and serverless and Lambda can be an interesting part of your infrastructure. You should definitely monitor. Just because it's serverless doesn't mean you can stop monitoring. You need to make sure that your functions are doing well and continue doing well in the future. So definitely want to keep monitoring. If you care about the demo that I did, you can find it at repo. That's what the QR code is. If you're one of the cool kids, you can use QR codes. If you're not, you can type. That's there. My name is Matt Williams. I'm an evangelist at Datadog and organizer of an event called DevOps Days Boston. Hopefully, I'll see you there later this year. Thanks so much. Yes.
You mentioned SQS.
Yes.
In one of the slides. Can you use SQS with Lambda?
Mm-hmm. So I don't think it will automatically. I don't know if it'll trigger on its own, but you can watch CloudWatch logs or CloudWatch, the CloudWatch logs for when SQS starts, and then filter based on that, and then trigger the Lambda from that. So in the CloudWatch logs, you can configure it so that SQS, as soon as a message comes in on SQS, it triggers a log message, and that's the way that Lambda could integrate there. Kind of a roundabout way of doing it. Another way would be have some process in an EC2 instance or in a Lambda. Well, no, can't. That won't work. That would be the only way. Not ideal.
Yeah. Any idea why? It seems like such a natural fit to have an SQS message fire on that.
Yeah.
Why?
I don't know. Yep. Okay.